Hello, and welcome to the virtual Kansas City SQL Server User Group Lunch and Learn Ninja Edition. Thanks everyone for joining. We're happy to welcome Jeff Iannucci to our user group today, presenting Defending Your SQL Server, Practical Strategies Against Ransomware. Such an important topic as these things become more commonplace nowadays. For our US folks, this may be a lunch and learn, but don't feel left out if you're joining us from somewhere else. Feel free to eat, snack, fika, anything else along with us. For the audience, this session is recorded and will be uploaded to our YouTube channel. If you have any questions, go ahead and pop them in the chat. And as usual, with our lunch and learn, we jump right in, and I'll let you take that away, Jeff.
Thank you. Thank you. I don't have anything to eat here, so all of you enjoy whatever snacks or lunch you're having. My name is Jeff Iannucci, and as I said, this session, Defending Your SQL Server, has come about because I am a consultant of sorts. I work with Straight Path Consulting, and unfortunately, we've seen lots of clients who have been victim of ransomware. And so we've kind of put this session together to try to educate people on ways that they can protect themselves and prepare for ransomware. Now, before I go any further, I want to point out that all the slides and scripts that you'll see are available at my GitHub repository. I haven't uploaded for this particular session. There are previous sessions where there'll be very similar scripts and slides yet. I'll try to get to that here later today or tomorrow as well. If you're wondering who I am, my name is Jeff Iannucci. And as I said, I'm a consultant with Straight Path Solutions. I'm also a content author at Pluralsight and an author of the book Learn SQL in a Month of Lunches. That's the SQL language, not SQL Server. I'm excited to talk about these accomplishments, but one thing about this session is that we're going to talk about a lot of things. And after starting to give this session and noting the scripts that are in there, if for whatever reason you feel like you don't want to run each of the individual scripts, we actually made something called SP Check Security. It's a free community tool. You don't have to enter your email or anything. You can go to the Straight Path Solutions GitHub repository, download that. We update it from time to time with new things that we found, other updates, and you just run this and it will tell you, hey, these are potential security vulnerabilities for your SQL Server. There's a lot of read more URLs that have even further information if you want to look into particular things. If you don't know, well, why is this an issue or not? Again, this isn't a commercial. In fact, let's transition quickly into story time now. If you are a database professional, maybe you're a database administrator, maybe you're the person that plays database administration as a sysadmin or a lead developer, and you're probably thinking about your data, right, as well, it's your babies, it's your eggs. You are the great protector of this data. But as we all know, unfortunately, there are people out there looking to take that data and do malicious things with it, right? So trying to hack into your systems. Imagine one day that you wake up and you find out, you're notified that, hey, our SQL servers, all of our servers, in fact, are unavailable. We can't connect to anything, and we don't know what's going on. And then eventually somebody gets discovers a text message or an email or even a text file that says, hey, you are the victim of ransomware, and you have to now pay the ransom if you want to get to your precious data, because it's all now encrypted, and the only way to get it back is to pay someone who has the encryption key. It's a horrible story, like I said, but we've had, unfortunately, clients who have fallen victim to this. Now, what we're going to discuss today is, a couple things. Like, first, we're going to have a really brief discussion about what exactly is ransomware. If the organization that you work for has not been hit by ransomware, that's great. But we shouldn't be thinking about these things in terms of just avoidance. We should also be talking about preparation. And the one way to prepare is to look at the vulnerabilities that we have and see if we can address those to minimize, our attack vectors within SQL Server, but also to prepare for, hey, there are other ways that there are other vulnerabilities that we have with our SQL Server instances, with the servers that they sit on. So how can we prepare to respond to ransomware? Now, I want to just focus just on that. We're not going to talk about things like cyber attacks, of other forms of malware that just do damage or put your data on the black market, things like that, or any denial of service attacks, things like that. We're not going to discuss those. Although many of these things could also potentially be thwarted with the actions that we take to try to prepare our SQL Server instances against ransomware. I know this is a silly question. Why should you care about ransomware? If you haven't been a victim of ransomware, and if you don't know anyone whose organizations have been, you might be surprised at some of the statistics. Now, I don't have any data for 2024, but as of 2023, Verizon conducted a data breach investigation report and found that ransomware was 24% of all breaches. I would venture to say that in 2024, that number's probably increased, because we do definitely see it involved more frequently in a data breach, because quite frankly, it's a profitable thing. There's now things called ransomware as a service, where if you, or not you, you're an upstanding individual, not you. If someone can provide access to data, then the ransomware software folks will partner with that someone to say, hey, let's split the profits from the ransomware. It's a horrible business, but unfortunately, it's still very successful. In fact, ransomware affected 66% of organizations in 2023, according to this report. So that's telling you in some way or another, people are having to respond to it. It doesn't mean that 66% of people were necessarily victims, but that they have to take actions. And also in the last 4 or 5 years, there have been more than 130 different strains detected. There may even be more. So it's not like there's one thing of ransomware that you could protect against. There's just, it's evolving so fast that, quite frankly, our defending technology can't keep up with it. All right, now that I've scared you, let's talk about what actually is ransomware and what happens with a ransomware attack. So it's broken into basically 4 steps. First is access. As I said, that's the main point of contention. If you can prevent someone from getting access to your environment, you've already won the battle, so to speak. Now, you may say, well, we have Microsoft Defender, and our sysadmins have things in place to prevent any kind of attack. But quite frankly, there are other ways to get in rather than a brute force attack. The most common is phishing. You probably had to take those HR videos. If you haven't, I certainly have taken plenty of these that say, hey, don't click on that thing that has an attachment. You don't know who it's from. So unfortunately, people are still clicking on things. And so that will infect their local computer. But then what happens is the ransomware software will take advantage of whatever access they have and start to do a discovery. And when it has that access on their local computer, one of the things they can do is go into SQL Server. We know that SQL Server has, well, it's certain capabilities set up, and depending on the permissions you've installed for SQL Server, it could be a lot of access to things. Things like, did you put your SQL Server service account as a local administrator? Because if so, if they can achieve access to your SQL Server, they can do things like, well, we'll talk about it in a minute, but to download malware that would infect the entire environment. And speaking of infection, that's the next phase. So once they have access, now it's going to install software that's going to start scanning your environment, trying to make note of as many different servers as possible, computers as possible. And it will try to escalate privileges so that it can do things like install malware on all those. You may just have only read-only access, but there's ways, unfortunately, to escalate permissions. Once that malware is installed, then the third step is encryption. Boom, you're encrypted. And then comes the ransom demand. When you get the ransomware demand, when your organization receives it, you've got 3 choices. Choice number 1, you can pay the ransom. And depending on the size of your organization, that could be millions of dollars or more. Now, many organizations have insurance to pay the ransomware. If you have a vulnerability and you can pay that ransomware, that's great. And the ransomware is paid, and they say, thank you very much for your business, and they'll give you the decryption key. But the problem is that isn't always the solution, because it could take days or weeks to decrypt all the files, if ever. Sometimes, in fact, there's a lot of times that there will be data lost, even if you do decrypt it. Now, you have another opportunity, if you get a ransomware demand, you can ignore it and completely rebuild your environment somewhere else. That means you'd have to restore all your data, at least from a SQL Server perspective, from the last available recovery point in time. But if you have a virtual environment and you have it replicated somewhere, if you have backup copies of your servers and of your database that can be restored, you have the ability to just sidestep the whole thing and say, you know what, we're just going to move all our stuff virtually over here. And there's option 3, which unfortunately does happen from time to time. Can even happen as part of option 1. You can pay the ransom, but if you can't recover your data, unfortunately, we saw a client that was unable to get everything back up in time, and over the course of weeks and months, they lost over a year of data and eventually had to go out of business. So this session is designed to help you prevent that, right? So even if you pay that ransom, like I said, recent data indicates that 16%, only 16% of folks managed to recover all their data. That means that, according to my math, 84% of people lost something. So again, you want to prepare for it. So how does SQL Server factor into this, right? SQL Server, as I said, can be an attack vector for your ransomware demands. Here's one that I found. I was looking through different articles that did talk about ransomware that did occur through SQL Server. I don't know if you remember the hack of Target a while ago. Researchers noted that it started with an infection in MS SQL Server and then compromised your machine, downloading a .NET file using command.exe and PowerShell.exe. You've used SQL Server, you know how to do this, right? XP command shell as an option. We'll talk about that here later, about how to prevent that from being used for this kind of an attack. Here's another one, another SQL Server attack that was noted in 2023. People were able to gain access by opening a CLR shell. Have you used CLRs with your SQL Server? Well, you can use those maliciously as well to escalate privileges and open up a shell as well to download things. Also note the malware picked up the system information and changed the compromised account's configuration and escalated privileges. We'll talk a little bit about that as well. And another final example here, the attacks start with a threat scanning for servers with open TCP port 1433, which I will say one thing about that. Everyone knows it's the default port. But even if you change the port, a simple port scanner, port sniffer can determine what port is used. So changing the port probably just complicates your life more than anything. Why that's not underlined. But let's talk about other things that are underlined here, which are likely a public-facing MS SQL Server instance. The attacker then carries out a brute force and dictionary attack to crack the password. Here's a pop quiz. What login do you think they're trying to crack the password for? We'll talk about that also here in this session. For the attack to work with either method, the target password has to be weak. Interesting thing, I did underline publicly facing MS SQL Server because unfortunately we have found clients that have that and didn't even realize that. So maybe someone set up your SQL Server and they didn't put it behind the firewall, and suddenly you have quite the vulnerability. Speaking of vulnerabilities, there's a lot of vulnerabilities in SQL Server. So we'll talk about those. We'll get down here to the meat and potatoes, or if you're vegetarian, just the potatoes of this session, where we'll talk about the actual vulnerabilities to look for, but first 2 principles, and then we'll get into the specifics. First, the principle of zero trust. I feel like I should have put something here. It's like trust no one from the X-Files, but it doesn't mean that exactly. But it does mean that we always want to authenticate and authorize based on all available data points. And this is kind of a key component that goes along with that. Not only do we want to verify explicitly through things like multi-factor authentication, we want to assume a breach. In fact, if you take nothing away from this session, I'll be disappointed. But if you take one thing away from this session, you should assume a breach? In fact, I know it's kind of a nervous thing to think about, but what if you have right now a breach? Because the infection phase of a ransomware attack can take weeks or months. It isn't instantaneous. They install the software and just leave it there to go find as much as they can so that when they do encrypt your environment, they encrypt as much as possible so that it's, well, basically as impactful as possible, right? As damaging as possible for you to encourage you to pay the ransomware. So if you assume a breach right now, there could be some malware already somewhere on your system trying to escalate privileges, trying to discover about your system. And when we assume a breach, what that allows us to do is minimize the blast radius by saying, hey, how can we segment our network? I don't want to get too deep into that because, you know, we're database professionals. We're not necessarily, I mean, maybe you are, but I'm not necessarily a network administrator. But if you can segment access, if you can implement certain other types of end-to-end encryption, if you can implement things to detect these threats as possible, then when you do have a breach, which again, assume that it happens, it will be minimally impactful. The second privilege I want to mention is the principle of least privilege. And you've probably heard this if you've ever had to set up permissions for people, which is grant users only the privileges which are essentially vital to perform these intended functions, their intended functions. It means you do not put everyone in the sysadmin role. You do not put everyone in the DB owner role because these things lead to other privilege escalations, right? We want to be very mindful of what database roles, instance roles, and server roles, right? Even outside of SQL Server, what roles we assign at the server level to our accounts. Heck, even the domain level, right? I actually saw a server once that had domain users in the sysadmin role. This is why I have gray hair. Anyway, to quote the great Dwayne "The Rock" Johnson, know your role. At least know your users' roles that they should be assigned to. All right. Enough conceptual stuff. Let's talk about your actual login vulnerabilities. Because all ransomware attacks start with access. And the very first thing to check for is your SA login enabled? Well, it's enabled by default. So if you haven't disabled it, it's probably enabled. Now, why is this a problem? Because every instance has and needs the SA login. And everybody knows by default it's in the sysadmin role. It needs to be in that, right? Because the SA login is going to own things. It's going to own the master and MSDB databases, other system databases. It's potentially going to own your jobs. You know, it's a very vital component to your SQL Server. Because of that, it's the most common attack point for a ransomware attack or any kind of breach through SQL Server. Now, what can we do about this? It's really easy. We can just disable the account. Disabling the account doesn't mean it can't do anything. It just means we can't have connections from users, which is what we want. The SA login still can work. It can still own jobs, own databases, do whatever you want it to do. It just can't be used for an external connection. I'll have here, as I said, various SQL scripts rather than flipping around and saying, look, let's look it up and how to do it. These scripts, as I said, are available on my GitHub repository that I noted at the beginning of the session. I'll also note it again at the end of the session if you missed it. But we can see really quickly here what it is. Now, interesting here, notice that I have where the SID, the SID is this value. That's always going to be the SA. Sometimes people will say, well, what if I just rename the SA account? That may break things, actually, because there may be some things that are linked to it based on name, but it doesn't really keep it from being discovered because all you have to do is look at that SID and it'll tell you what the name of that account is. All right. The second biggest attack vector within your SQL Server is the sysadmin role members, because the members of sysadmin can do anything in SQL Server. They can change other people's permissions, add or remove other sysadmin members, turn things on, turn things off, stop databases, back them up, drop them, whatever. please review periodically your current sysadmins to make sure that only accounts in there are ones that need to be in there. And if possible, avoid SQL Server logins. I mean, leave the SA one in there, but disable it, of course. But otherwise, we want to avoid SQL Server logins. Remember, we saw that there was a brute force password attack. Well, that's going to happen against a login, and it was probably against the SA login. You can see who is in your sysadmin role, who has these privileges, and if their accounts are enabled or disabled with this query as well. Now, there's kind of a hidden sysadmin role that's called control server. Control server permissions are virtually identical to sysadmin. But the thing is, it's not a role. It's a permission that's assigned. So if you aren't looking for it, you don't know if someone has that. You can't just easily go in Management Studio and find this information. The thing about control server permissions is even though they don't have exactly the same permissions as members of the sysadmin role, they can impersonate members of the sysadmin role. And because it's not a defined role, it's often unnoticed. What I've seen the control server permission used most frequently is if an application is installed on your software, or excuse me, on your database, and they'll create a login. And with that login, they'll assign control server permissions rather than throw it in the sysadmin role, which people might say, hey, why is it in the sysadmin role? They'll assign that login control server permissions. And now you're just one guest password away from complete vulnerability for your instance. Anytime I see this, I ask, why are we using this at all? Why would we have these hidden permissions? You can find these permissions as well. Also, local administrators outside of SQL Server. Right now, we're looking at the actual server itself in the administrators group. This is a Windows level group here instead of outside of SQL Server. Back in the day, this group was put into your sysadmin role by default, built-in administrators, but at some point Microsoft stopped doing that. Said, "Ooh, that's probably not the best idea. We don't necessarily want to make these people sysadmins by default. It'll show up as built-in /administrators in your SQL Server permissions. But the thing is, members of this role can actually add themselves to the sysadmin role. So if someone compromises a login of an account of any kind that is in the local administrators group, well, my colleague, Mike Lynn, wrote a post that's commented here that you can actually add yourself to the sysadmin role and restart SQL Server. And then you're in even though you didn't have any permissions before. Now, we wrote this post as a response for database administrators to say, hey, I got locked out of SQL Server. I need to get back in and change things. That's what this is for. But as you can understand, people might use that ability maliciously. So be very vigilant about who is in your local administrators group. All right, now a fun one here. This is the slide that I always get lots of looks when I give this in person. I'm giving this virtually, so I don't know if you're looking at me or not. I'll just take it for granted. Password issues. If you have a blank password, which you can't do now in SQL Server, but you could years ago, and so if you created a login with a blank server or blank password, it's carried over as you migrate from one instance to the next or you upgrade it. If you have a blank password, that's definitely an issue. If you have a password that's the same as the login, yeah, we've seen that too. And if the password is actually the word password, that's an issue. If you are in the sysadmin role, and again, we want to keep these members to only the people who need this. If you are one of the eagles defending the database here, you can find these. There's a function that allows you to compare. You can kind of sort of guess, I guess, but you can compare a character string to say, is this the password of any account? And then you can find any logins. And it will tell you from, as we talked about, I briefly mentioned the SP Check security that we use to perform security assessments as part of our security assessments for our clients. I can't tell you how many times I have found accounts that have either blank or the word password or the same as the login. It's really fun when you find those and they're in the sysadmin role, because these are going to be the easiest passwords in the world to guess. Again, I'm sharing this information with you to find it and then go back and whoever owns those accounts to have a conversation with them to say, let's make these a wee bit more secure. But really, I just want to ask you about SQL logins altogether. Other than SA, which is required, why do you even have them? Avoid them if at all possible, because you can't multi-factor authenticate them. You can't tell who's using them. I mean, the only way you could potentially tell is if they're failed and then you capture the failed login information, or maybe you have an audit, but even then it's not going to tell you the actual user. It's just going to tell you the location or the program that's using it. So I would suggest highly, please limit permissions for SQL Server logins to the best of your ability, and be sure to create secure passwords for these. Now, this is another fun slide. I can't speak to the validity of this entirely, but this was a slide that was presented a couple of years ago about what is a secure password. Please don't use this as some sort of absolute truth. In fact, just consider it, though, what happens as we add complexity to passwords. Now, according to this, if someone has some kind of attack software to try to guess your password randomly for your SQL Server logins, if you have 11 characters and their numbers only, they can guess them relatively instantly. That means less than a second. That's how quickly it can process all possible combinations. But as soon as you start adding lowercase and uppercase letters and numbers, and combine those with symbols, look at that complexity. That now 11 character password goes from instantly to 3 years. So this is why you always see people like, hey, you need a complicated password. And you're like, how am I supposed to remember that? You definitely want to use passwords that are at least 12 characters, at least. Because when I look at this and I see 12 characters and it says 226 years to guess that, even if it's not 226 years, if I've mixed it up enough, I've created enough of a problem that it probably can't be guessed. 16 characters or more are even better, especially when you're using these different variations. Try to avoid using words because password library attacks can guess words. Try to keep them as nonsensical as possible so that you don't have accounts getting hacked. And put one of those nice 16 character passwords on your SA account too. All right. On your SQL Server to find out. Now, I noted that there was one attack that said, hey, this was a publicly facing server. Well, you can tell if it's publicly facing. You can go to a server other than that server, something outside your network. If you're not VPN connected right now, you could just say, all right, I'm going to ping the IP address if you know the IP address of the server, and do I get a response? Again, we've had at least one client in my time with StraightPath that had a publicly facing database server. We had to then assume this server's been hacked because it's publicly facing. The public includes all those hackers in Russia and North Korea. And yeah. All right. So if you do have a publicly facing server, that begs the question, should this even be a publicly facing server? Or do you just have your firewall configured incorrectly? Maybe somebody didn't know what they were doing. I'll say that gently as possible, but to have people double check, And if you don't know your IP, try to find your IP. There's various ways to find it out for your server. You can go to the server level. There's a network property within SQL Server that will tell you that. Tell you the local IP that's attached. Know that IP address, especially in case you ever have to rebuild these servers. Again, that's one of the ways to prepare for ransomware attack we'll talk about later. But we did mention, you may have to just rebuild the environment. Well, if you know all the IPs, you can do that relatively quickly. Again, just check to make sure you can ping the server. Now, before I go any further, I have noticed some comments popping through here. Did anyone have any questions of anything? I just see little pop-ups. I don't know what the actual questions are.
There's not been questions that have come through.
Okay. Okay. Have they been insults? I hope not.
No, no, not at
Okay.
all.
All right. All right. We'll keep on moving then. Cumulative updates. Now, this is one of the more important things. They say, all right, keep your servers patched. And I know that a lot of times Microsoft will release updates that kind of do bad things. And then, they'll either release a quick hotfix or another update or pull the update altogether. Not saying you should apply these updates as soon as they come out. But this is an old screenshot that I'll point out for a reason why I use this. This isn't the most recent updates for your SQL Server. But these cumulative updates contain vulnerability fixes often. And I want you to pay special attention to these things that say GDR. A GDR, I think, stands for General Distribution Release. But almost always, these are including security vulnerabilities. And these security vulnerabilities, if you click through on them, this is, I'm using SQL Server updates. There's also other sites that list them. This is just a cleaner way to display in a nice slide for me. But to see whenever you have these GDRs released for your SQL Server instances, you can go to the Microsoft page and click through the list of vulnerabilities and then say, all right, I'm going to click on each one of these vulnerabilities, and they'll have an assessment there. And the assessments will say, this is, our threat level is high or low. The complexity of this vulnerability is high or low. The permissions required to take advantage of this are high or low, and other things. And then they give it a grade on a scale of 0 to 10 of how vulnerable they are. Now, I have seen, especially last September, October, and November, Microsoft, in the course of 3 months, released vulnerability updates, one each month for each of the supported instances of SQL Server. So we're talking about 2016, 17, 19, and 2022. And each of those months, there were vulnerabilities that were up to like 8.8 or higher out of 10. Who else do you think knows about those vulnerabilities? Now, even though Microsoft won't specify what they are for obvious reasons, they will talk about, hey, this is a vulnerability based on your ODBC connection or an OLE connection or some other component of a SQL Server or the connectivity thereof. So I highly recommend creating an update schedule to apply these updates, to apply regular updates, which include security updates, if you haven't been updating your SQL Server, to address these vulnerabilities as they are discovered and hopefully corrected by Microsoft. Now, SQL logins. There's the basic logins. We know what it has. This is, I would encourage you to, let me back up. SQL login audit. This is the audit of, did people connect to my SQL Server or not? Now, by default, it doesn't include failed logins or successful logins. It just doesn't put that stuff in there. You'll see this screen if you look at the properties for your instance. And it doesn't include any failed logins by default. I would suggest that you start auditing failed logins so they show up in your error log, and then either manually look at it or set some software to look at it or a report to look at it. What this can do is, by looking at failed logins in your SQL Server instance, we can audit the failed login attempts that could reveal a hack attempt. If you see hundreds or thousands of failed login attempts, because SQL Server isn't like your Windows, you can't just set up and say, hey, after I fail 3 times, lock me out for 15 minutes. No, you can keep trying. And so when you see all these failed attempts, it usually means one of 3 things. First, it's a hack attempt, it's a ransomware attempt. And so we want to make people aware of it. Second, it's an attempt to do some sort of security or penetration testing, which hopefully they would let you know after the fact. But it's, hey, kudos to you if you can find these things ahead of time and say, it looks like we're being hacked. And then your security team says, oh, no, we were just doing some testing. Good catch there. Remember that next time your salary review comes around. Third thing, and this is also very common, is that someone changed a password for some commonly used application, and they didn't change it in one application And so then it just keeps bouncing back and forth against SQL Server. Hopefully it's the second or third option, but it sometimes is the first. So anyway, check your SQL Server logs. If you don't want to just open it up and just have a wall of data, you can use a function called spread error log, which will allow you to go look for failed logins only and then collect that information. Again, you can use this, leverage this to build like a job or whatever to send you that information every day so that you have that. It's up to you with your creativity. You may even have monitoring tools already that'll tell you this stuff, which is great. I'm just providing this in case you don't. All right, link servers. Ask any DBA what they think about link servers. Problem is that most people can't set up the security context correctly for a link server. They get really frustrated, like, I just need to connect to data over there. I'll just set it up using the SA login or some other sysadmin. Well, don't use SA. We want to disable those accounts, right? We don't want anyone, especially the bad people, to use the SA login for anything. But even if you use a sysadmin account just because, oh, I couldn't figure out what permissions were needed for this account, so here you go. What that effectively means is that anyone can connect to the server with the linked server and use it can now be a sysadmin over on the other server remotely, querying however they want. Remember we talked about privilege escalation? This is one of those ways that privileges can be escalated. So I'm not saying don't use link servers. I'm just saying make sure, try to use the highlighted option here to use the login's current security context and work out the permissions. Do the hard work to save yourself a lot of harder work in the future. All right, CLR enabled. We saw that at the beginning of this session, one of the attack vectors was to use CLR enabled. Now, this is not an option that's enabled by default. What does this do? It allows the user assembly execution, and anything can be included in that, right? So sometimes we can't do things. These CLRs, we started using CLRs, I want to say, when was that? SQL Server 2005, maybe? Because there were certain things we couldn't do in TC. We couldn't split strings, things like that. Well, since then, we have made advances in our T-SQL. There have been feature additions that probably allow us to do almost everything we need. So I would say if you are still using CLRs, go back and see why do we need these at all? Because they're kind of a mysterious little black box that could be can be doing anything on our SQL Server, malicious or otherwise. Now, starting in SQL Server 2017, Microsoft introduced something called CLR Strict Security. It's recommended that you use that if you need CLRs instead of CLR enabled, because what CLR Strict Security will do is it will treat all assemblies as if they are unsafe and let them only operate in the context of whatever database they're supposed to execute. CLR enabled allows you to change the settings of whether it's safe or unsafe, and you can get a whole lot more done than you need to have done. And I mean that in a bad way. So definitely recommend seeing if you have this enabled you can tell if you have CLR enabled on any of your instances. And if you need it enabled, test CLR Strict Security to make sure that that will work for you. Now, XP Command Shell enabled. This allows us, a user, to open up a command shell, effectively a DOS prompt, right? And then go do things outside of SQL Server. Look around for servers, query Active Directory, download malware, all kinds of fun stuff. Anything you could do from a DOS prompt, you could virtually do through an XP command shell. Now, it's not enabled by default and allows you to execute external commands, including PowerShell commands. But here's why I don't freak out about XP command shell if I see it enabled on a server. There are two things to remember about that. First, only members of the sysadmin role can even use the XP command shell. If you're not in the sysadmin role, you can't do anything. And if you're in sysadmin, you can enable or disable that setting anytime you want. So the real issue here, who is in your sysadmin roles, right? Now, if you want, you can check to see if XP command shell is enabled. But if it is, then ask, Why is this enabled? Who's doing something with this? I've seen back again, I've been a DBA a while. So I remember years ago, we would use XP command shell as DBAs to say, well, I'll go and, query a directory and get a list of files in the folder or whatever for something. There are other tools to do this now. You may not need to use this. You just need to update your code. I'm just using that as one example, but to find out, again, why are we using XP command shell? And then even better yet, hone in again on who are your sysadmins, because they can use this. Even if it's disabled, they can enable it. All right, let's move on to backup vulnerabilities. Why do we care about backups? Because if we have encryption, we have to rebuild everything. Well, we got to start with backups. So here's the question. Do you have backups? Native SQL Server backups are great. They allow for point-in-time restore, have all kinds of flexibility. They enable compression and checksum in there to validate that the backups are work. The compression option, if you're not using it, is a great option because unless you're backing up tables with image data, you're going to get a reduced size and you're going to get a faster backup most of the time. We'll say VM backups don't necessarily count because someone will say, well, we've got VM snapshots of the database. Well, have you tried restoring that, right? The problem is that those backups will just back up whatever's on your database. Oh, did someone just point Ola Hollingren? Yes, that's a fantastic option. And the gold standard of native backups now for over a dozen years. The VM backups, the thing about virtual machine backups is test restoring from them, because if they're not application aware, they're not actually telling SQL Server, hey, I backed you up, and they're just backing up blocks of files on drives. And if they don't do those all at the same time, and if you've got your database data files and your log files on different drives, which many people do, you probably should actually, depending on your hardware configuration. This is not that session, but if you have them set up on different drives, you may not get those things backed up at the same time. And if there's a transaction in flight where the data and the log are not synchronized, when you go to restore that, your database could be in a suspect mode. That's a bad thing. Then you have to restore it from backup usually. Yay. Okay, so it could be application-aware backups, which means that they often will be copy-only backups, but at least they'll tell SQL Server, hey, I backed you up. Okay, thanks. They're not backups like native backups. They don't back up everything. They just back up data changes. And even more crucially, a lot of times I've seen people install this third-party software that's backing up their virtual machines or even backing up just SQL Server, and it doesn't include the system databases. Don't you need those? They have your logins, your jobs, all the other things that make your SQL Server instance very unique, things that you wouldn't want to have to try to piece back together after the fact. And are you copying your backups off-site? Or are you writing the same place that your servers exist, so if you had encryption, your backups are all encrypted too? Which brings you to the biggest question, have you tested restoring these, right? The great thing about a DR test, it will reveal things you wouldn't have even thought of in the process. One of those things is how long this takes to put a server back together, especially a database server, to get an application to be able to use it. Might be longer than you think. Now here's a script to check for full backups. It's a long script, I know, but this can tell you some information about, hey, where are my backups? Do I have any? Where are they going? Things like that. This is just for full backups. We also want to talk about log backups because you're not taking full backups all the time, but you are probably taking log backups. Again, native log backups are great to get to a point in time recovery. If you said, well, I know, even if it's not ransomware, I know I had a data failure at this point in time at 12:44 on Thursday. I need to restore everything up to that point. You can do that with a log backup. Again, compression checksum options included with these as well. And here's another funny thing. If you have application-aware backups for those third-party backup softwares, go check and see, well, what's it doing with the log? Is there something called clear, or what does it say? It says truncate log on backup. Oh, that sounds good. I wanted to free the log space. Cool. Well, what it's actually doing is it's backing up to null. Null with one L, not two L's. And it will back that up to basically nothing. It just says, I read it, and then I told it it's good, but it didn't back it up anywhere. It means it's not recoverable. Again, go check and see about that. We have a script here to see, well, where are these backups going? Are they going to null? Or are they going to an actual file or virtual device or cloud location, whatever the case may be? And as I said, not only have you tested restoring for your backups, have you done a point in time recovery test? And then here's another fun thing. You may say, well, I've got native backup set up, and then the sysadmins, they're just running their backups. But do you have a backup chain inconsistency now? This happens if you have multiple backups in different places. What if you have native backups backing up the transaction log every 5 minutes and the database every day, or whatever the case is? But there's another piece of software that's doing the exact same thing. It's just doing it at different times. If you had to try to recover from that, it's impossible. You don't know, well, which full backup's the most recent? Now I got to go figure that out. Which full backup was, or where are my log backups? How do I apply them in order if they're in different places? My colleague David Cease wrote a post about this on how to audit your database backup chain. Now you can see there are some backups, you may have multiple backups, but if only one of them's not copy only, if the rest are copy only, then you probably don't have a backup chain that's broken. You just need to know which one to use for recovery. Again, it sounds like a broken record. Have you tested restoring? Here's the link to that. Now these last few slides I know were pretty complicated. We've got a script here to go look for my full backups or my log backups, and then there's a script here. Excuse me, there's a script here that'll see, well, what's my backup chain look like? After I gave this session the first time last spring, we went and created a new tool as well called SP Check Backup. It'll tell you all the information you have as well, rather than have to figure out these scripts. Again, this isn't a commercial. These are free tools. Just try to make things easier for you to help you prepare. All right, speaking of preparation, insofar as it depends on you, what can you do? Now, I promised in the abstract for the session an actionable list. So let's talk about things you can actually do now that you're armed with knowledge about what's going to happen. That tactical vest looks like it may just be a bomb. I don't know. The AI did its best, I think, on that one. Okay, first thing you do, identify all your instances. You can't protect them if you don't know them, right? I don't know how many times I've walked into some place and then they said, okay, you're the DBA. Well, where are all the instances? Nobody knows. Well, then you go ahead. Thank you for that comment. You go ahead and thank you for your service. You go ahead and document all your instances. Make a spreadsheet, right? Use a database. Hey, why not, right? You use databases. Track down your server and instance names, the communication protocols and ports used, the IP addresses, any resources like the drives assigned to it. Grab all that information in case, and just have it standing by. You just need to grab it once, or at least once every year, whatever the case is, to know this information to say, in case you need to rebuild these servers. Go look and see if they're externally facing, and if they are, freak out. But if they're not, confirm that they're not. And if you didn't find them all, there are tools. This is a PowerShell tool called Find DBA Instance, which will help you find all the SQL Server instances you have installed in your environment, assuming you have adequate permissions to go discover that. Very helpful when people say, oh yeah, I forgot about that instance or that server, to help you find those things. Review your instances. After you've got that information, now look and see, do any of these need updating? Have some of these never been updated? Probably. Go look and see what the most recent updates are. Give yourself 30 days or whatever to make sure that they haven't been pulled or that you haven't seen in forums or elsewhere any issues related to them. And develop a cadence, some sort of schedule for applying those updates. Also, check your linked servers to see what kind of security context they're using, and check for CLR usage. And if possible, see if you can use CLR strict security. Test it in dev, don't just switch it in prod and break things. And also make sure you're capturing those failed login attempts and reviewing them daily if possible. We can do that by checking the IP address. It'll tell you anytime there's a failed login, it'll say, here's the login that was failed and here's the IP address it's from. If you need more information to see what in the world is happening here, you can use extended events or SQL Server audit to capture even more information. SP read error log is something you can use to review those failed logins. Here's a link here to how to use that, different ways to use that. As I said, you could set up a job, a SQL agent job, to maybe do that work for you and just send you and say, hey, we had 0 failed logins, or we had 1,000 failed logins yesterday. You can write SQL queries, hopefully. Next, let's limit the SQL Server permissions. This is very critical, right? See, let's disable that SA login. If you're not sure if you can disable that SA login, again, like the last slide said, extended events or a SQL Server audit can help you see, well, who's using the SA login? If nobody's using it, fine, let's disable it. But if something's using it, let's find out who is using it, dissuade them from doing that. Or, unfortunately, if it's an application that's using it, let's go create a different login for that application and then change it. Check for password vulnerabilities, and always implement the principle of least privilege. We don't want to make sure we don't have anyone in the sysadmin role that needs to be there. We don't want anyone in the local administrators group that doesn't need to be there. We don't want anyone to have control server permission that doesn't need it. And if they do, let's ask, why aren't they in the sysadmin role? I would actually add to this slide, but I'm running out of space, the security admin role as well, because anyone in the security admin role on your instance can create a login with control server permissions. See how that works? Permission escalations. Let's also see, are there any SQL Server logins, not Windows accounts, SQL Server specific logins with these permissions, and try to reduce those as well, because you're just one guest password away from something having full control. Use strong passwords for SQL Server logins. This is probably a good way to guide you. Again, this isn't the actual way. There may be technological advances that make these not take 5 billion years to guess a 16-character password. But hey, if I can just keep them to 1 billion years, I feel comfortable. Verify your schedule of backups. Make sure you have backups. How often are they? And how many things are doing backups? Is your backup chain broken? Do you have log backups, or are they going to null? Are they going to nothingness? Do you have backups of the encryption keys and certificates, right? If you have turned on transparent data encryption or use any other form of encryption for your SQL Server, do you have those keys stored somewhere that in case you had to rebuild your whole environment, you could use them, because otherwise you can't restore your backups, right? That's the great thing about encryption. Unfortunately, you don't want it to be encrypted from you. Testing helps with all of this to discover these gaps you may have. Make sure your backups are off-site, that that's basically a way of segmenting your network, right? I've taken these backups and I've put them somewhere. It's weird. My first database job that I had in the 90s, we had backups to tapes, and I would walk them to a bank and put them in a deposit box. And now people are doing that again because of all the possible ways to virtually hack into any environment. And then you have those vulnerabilities. It's like, well, at least we have physical copies of things. I'm not saying that's what you need to do. I'm just saying it's interesting that this is kind of the direction that we're going. Also know, what is your recovery point objective? Meet with your colleagues, management team, and say, how much data can we afford to lose in that? And say, all right, so are we taking backups frequently enough and moving them offsite enough that we can fall within that recovery point objective? Test something that's called recover from zero. Assume you lost everything. Remember I said assume a breach? Well, assume that tomorrow you are the person, you are the eagle with the phone. Somehow eagles have fingers on their wings, but you're the eagle on the phone that says, that gets the call, hey, we can't access anything in our environment. When that breach has occurred, assume you have restored a database from backup. You've practiced that. Now, you've probably done that. I'm sure you've refreshed a non-prod environment, but have you done it with your largest database? Have you done an entire server? Have you done multiple servers? Do you know how long that takes? All these things take, because when you have to recreate your environment, this is what you're looking at. So in addition to your recovery point objective, how much data you can lose, what's your recovery time objective? How long it's going to take you to get things running again? Again, check with your colleagues. Make sure you're employing the principle of zero trust. People only have the permissions that they need, that your systems and network administrators are using antivirus software according to Microsoft's recommendations. This is a link. If you use SQL Server, bookmark this, because I don't know how many times I've had to share with the sysadmin something to say, hey, configure this and put these exclusions in place so you don't wreck SQL Server, so you don't crush it with performance issues by you're trying to do virus scans against data files, things like that. Try to use multi-factor authentication. It's 2025. We should be using multi-factor authentication. And I know, again, phishing is still the most vulnerable way to get access and then start breaking into your having a data breach there. I know we'd like to get our colleagues to stop clicking on emails and attachments, but understand this is why we prepare, because somebody's going to click on something at some point. You have all your action items. Now you can go and do all the things. I'll leave you with this thought. Ransomware affected 66% of all organizations in 2023, and just 16% of those who were infected with ransomware managed to recover all their data. This is my final slide. So it has the presentations, which will have all the information you're doing. There's a LinkedIn. If you'd like to connect with me, feel free to connect with me on LinkedIn, and then the links to check security and check backup. I promise this is not a commercial, but feel free to go read those and download them and see if they can help you prepare for ransomware or any other kind of data breach, or really any other kind of problem. That's all I got.
We did have a question come in that I missed right after I said we have no questions come in.
It was like a half hour ago.
Yeah, and then you switched to backup, so I was like, oh, I'll just wait. So the question was, even if we complete the SQL Server cumulative updates, are there certain server level or database scope configurations we need to have enabled for the updates to fully propagate?
No, you just need to have the adequate permissions to apply the updates. But as far as SQL Server updates, you just apply those. Generally, you'll restart the server because you can't apply another update until you restart it. But just to make sure everything has taken effect. I would say, though, if you do apply an update, and sometimes those updates, after you restart the server, your instance may not restart, or you may have some issues, you can go under Windows features with the newer versions of SQL Server. I'm assuming we're not talking about 2008 R2 or anything like that, but with the newer versions of SQL Server, they will show up as features under the program, add or remove program features, and makes it really easy to uninstall those if you do have a problem with those. Only mention that because I've seen that happen.
I know a long time ago, so here's a question I have. A long time ago, back when I used to do DBA type work, there were some rules around, and it was more of I did a kind of thing, all the things. But there were rules around like, oh, maybe you with SQL Server jobs, using a certain, account for running those or ownership of databases. Does that still apply?
Yeah, it depends what you're doing, right? You would still want to have certain accounts that can run things. I mean, the SA account's a great example of that. But if you want other accounts to do things other than backups, like you said, running things, sure, you could set up a login. Again, the key thing here is we don't want a login to be something that can be used by a user. If you have to set up a login, disable it. Now, I understand that this is the real world, and if you're using vendor-supported applications, they're often set up with a login instead of giving you the option to use, a service account. A group managed service account would be awesome, because then you don't have to worry about changing the passwords or having people use it. But they may not have those options. It may just say, oh, well, it has to be a SQL login, and it has to have these permissions. So again, if that's the world you find yourself in, I would highly recommend then taking the steps to say, all right, well, what can I do to audit this login's usage? Who's using this? Things like that. So.
Fantastic. Well, I don't see any more additional questions, but thank you so much. I did put the link that you had to the GitHub earlier in the chat. So Again, everybody, the additional links are here on the slides. And thank you so much, Jeff. We really appreciate you coming and speaking with our group today.
Been a pleasure. Thank you. Thank you for having me.
Thanks. Bye, everybody.